All right, I'm going to walk you through this functional design document. So this is the sample design document, and it lays out the design for a simple tic-tac-toe game. So here's the function names, the description. This is what would be in the documentation string. The arguments, that's what actually would go inside the parentheses. That's the arguments that go to the function. The return value, if any, that's what the function returns. And then final, how I would design the tests. Hopefully that's going to make a little more sense to you by the time I've walked through this. Before we dig into the particulars, it's actually easiest if you just go to look at the main loop. The main loop will show you how the program is actually designed. So when you run the program and you're not in testing mode, but you're in playing mode, this function called play game is what's going to be run. And this is going to show you what actually happens when that runs. So we're going to run this function called initialize board, given a board size, and that will return a initial board. Then we're going to flip a coin, basically, random integer 1 or 0, to see if it's the human's move or not. And we're going to check the board for victory. Obviously, there won't be a victory at this point, but we'll check it continuously. And then if it's the human's move, we get the player move with the board. We run that function, which is going to return a new board, and we say it's no longer the human's move. If it's not the human's move, we're going to get the computer move with the get computer move function with the board, and set the board, and then we're going to say it now is the person's move. So we go back and forth, human computer, until this thing returns something other than something true. So a string is true. Anything other than none or false is true. Once that returns something, we're going to print, and the winner is check for victory board. So check for victory, actually, when there is a winner, is going to return the name of the winner. So X or O, or maybe no winner, it's a tie. Okay, so that's a pretty good basic function design. If we go up here, we can see more specifically the plans for the different elements. Actually, display board didn't show up in this main loop, but display board would presumably be part of this get player move function, because in order to get the player's move, you better show them the board. So display board is a good starting point, just because it's simple. It's going to display a tic-tac-toe board. It takes the board, which is a list, and here that's returned by initialize board, a list the size of side size squared. So that means if it's a side size of 3, 3 squared is 9. So it'll be a list of 9 items. So that makes sense. And here it explains test function should call this with a variety of boards. And there's some example boards as I imagine them. So if I come to my code, here's the code I'm starting to write. I went ahead and pasted in my play game, although this function probably won't work yet. We'll have to troubleshoot that later. And then the first thing I'm going to do when I create the display board is I'm going to create the test. So define test display board. And here's my array of 9 items. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we display the board. And then it's probably worth putting some empty items in there too, to see how that looks. So I think I had said none. So we'll go ahead and put none in for those. You could also, it might actually be easier if this were just an empty string. It'd certainly be easier to display. So maybe I'll change my spec. And you can do that at this stage. You just got to make sure you decide now. So maybe I decide here those are going to be empty strings. I would update all of those if I were so inclined. Okay, great. So, and then I test it again. So test board. Lovely. So that's going to run my test. Now I actually have to create the function. Define display board. That takes as its argument a board. And we'll go ahead and print the board. So we're going to need to get the side size, which is going to be a square root of the length of the board. Square root actually just determines a float, so I'm going to go ahead and make that an integer. Now for row inside, for call inside, print. All right, lovely. We're going to go ahead and for each column, we're going to print out our items. So board, and this is going to be some index integers. This is a little bit fancy. You don't have to care too much about what I'm doing here. But if you're doing something similar, you might you might want to look at the list tutorial, which will walk you through what I just did there. And then the comma just says don't end the print statement, so we can print them all across one line. When we get to the end of the row, we print, and then that'll give us a new line. So there we go. That should look pretty much right. And now I've written my display board. I've written my function. This test can't really fail because all it's going to do is just print something out. So it can only fail if there's like something like I just had, like an indentation error or something like that. So what did I do there? Oh, I forgot to indent within my while loop. So that would be a mistake. All right, let's try that again. All right, and there I forgot for row in. I forgot to do the ranges there. So this is actually a good reminder that even anybody, no matter your experience level, you're going to run into lots of errors as you get started. I mean, I just ran into 2 errors writing sort of nothing. You're probably going to run into more. So here it is. This looks pretty good with the, oops, that look, let me, I'm going to, notice my test actually made it a little hard to see the board, so I might add some print statements and then clear it. Displaying board with empties. All right, so let's try that now. I'm going to run my code again, and we can see it looks pretty nice. With the full board, it looks a little worse with the empty board. So if I were working on that function, I'd go in now and figure out why that looks bad and how to make it look better. But I'm not actually going to write that now, so I'm not going to care too much. So that'll be job 1. But if we're just actually building out the tests, we don't actually need to write all this code. So I should also mention that that test ran because at the end I have this if testing run that test display board. So every time I want to add a test to my test suite or get rid of one, I got to add it here. So my next function, let's say, is going to be check for victory, and I'm going to go here, def check for victory. I'm going to test the check for victory, and so now the winning boards, I'm going to have to think about the different things that I might need to test for. So for example, X winning versus Y winning. And then the last thing I want to do is maybe tie. And then I've got one more state, which is no win boards. So I've got 3 sets of boards I need to test. And for each set of boards, I'd probably then end up writing a loop that's going to look at them. Now, if I think about the different kinds of victories I could have a cross, right? So that's one I want to test. And I could have down. Now, if I look at this, this is starting to get really complicated. I've got a whole lot of tests here. And if my tests are getting complicated, that means my function is going to get way too complicated. So I just had a pretty good sign that this test check for victory, probably I should break it down. So I'm actually going to make a test check for rows. And I'm going to make a test check for columns. I'm going to make a test check for diagonals, and so on and so forth, because those are going to be a whole lot easier to test. So, for example, now I would have to go ahead and populate all these different fields to give O's and X's, because I really do want to test all the different possible outcomes, because it's easy to make mistakes in code that would lead to these outcomes not quite working right. But there's a test for column, and again I could have more than one of these boards, and so on and so forth. And then what I'm going to do is I'm going to have some code, something like, for board and X winning, boards, check for rows, board, and that should be equal to X. So if it's not equal to X, print error, checking board returned, and then whatever it returned. So that's the idea, and then I'd go through and write that for each of these, for X winning, Y winning, tie winning, and no winning. Make sure that works. So that's a whole bunch of tests I'm going to run. I don't have to run multiples. I could just do one of each, depending on how confident I am in my code. But you can see that I very quickly noticed that the fact that I was going to have like 2 screens worth of tests was a sign that I needed to break that problem down. So instead of just doing a test check for victory as I planned, I'm actually going to test all these different things. And then I'm going to make a, so up here I'm going to end up with a function like check for victory, which takes the board, and that's going to call check for rows. And then I'd have a check for rows function that would do that. So, and it would say, basically if check for rows, or, each step it might say, winner equals check for rows, if winner, return winner. And then we go no winner, check for calls board, if winner, return winner, check for diagonal, and you see the idea. So this is pretty complicated anyway. This is like 6 statements, but imagine if we put all the logic in there, this function would get way too big. That's all the ways you can win, and then build a check for cats game, winner, return winner, and then otherwise return none. This isn't necessary. I'm just going to write return none just to remind myself I'm doing it intentionally. So return none by default. So this function now is going to rely on a whole bunch of other functions. And you can see how very quickly I just created work for one member of the team. This could be one person's whole day's work, is writing each of these functions to do all of these checks. And more importantly, also writing the tests. So test check for calls, test check for diagonals, test check for cats game. And for each of these tests, you're going to end up doing code like we did here in check for rows, where you're going to go through, you're going to call check for rows, you're going to make sure it gives the right response, and if it doesn't, you're going to call an error. Now that person is going to come down to the bottom here, create this code. Now they probably only are going to have one that they're working on at a time, so while you're developing, you might end up commenting these out and just testing the one. But when your team is done, you should be able to run the whole suite of tests, all these test functions, and they should all pass. You should see lots of good output. It tells you you're doing your job. And then, of course, you can find the run the play game function and test that. But this is test-driven development. It makes sure that you have defined how you're passing data from one function to another, what the return values are, and how you know if your pieces of the program are doing their job. If you can't write a test for something, it's probably too complicated to be a good idea. If your test is taking up more than one screen to write, it's probably a good sign you should break it into multiple tests. Similarly, if your function is taking more than one screen to write, it's a good sign you should break that into multiple functions. All right, I hope this has been helpful. Good luck. Thank you.